So at this stage, we've already reached a pretty important milestone. We're able to run our original DLT pipeline in our Dagster environment, which is great. But I think we can go even beyond by adding a few elements to make this project even better. Let me head back to our code base and I'll explain. So let's head back to the original Dagster pipeline script and let's look at the config. Specifically, I want to look at two endpoints. The first is issues, in which we're using incremental loading. And in incremental loading, here we are providing a initial value with a hard-coded value. We're doing something similar with forks, which is our endpoint for backfilling. And here we're also providing a hard-coded value for the initial value. Now, this is fine as it is, but what it means is, if we want to tweak any of these values, the time window for backfilling or the initial value for incremental loading, it means we would have to go to the script and, tweak this every single time, which is not really elegant. Ideally, once we create the script, we should be able to run our operations without touching the script again, right? And if we want to change a parameter, we should be able to do it dynamically. So that's going to be our first focus. Let me go back to assets. And in the script, I'm going to basically modify the GitHub source that we've imported. And we're going to replace our hard-coded values with the dynamic values that you can set with an environment variable. So first is I'm going to replace hard-coded till loading parameter. And the second one, I'll replace hard-coded backfilling parameters. And let me just remind myself what endpoints they are. So the incremental loading is the issues endpoint. And the backfilling parameter is, is forks. So now you might be wondering, we've already defined our source. So how are we going to change the config after defining the source? And well, there's a pretty nifty DLT function that serves just for this, that exists just for this use case. And it's called apply hints. And I'll show you how to use it. So first, of course, we need to have the name of the source object, which in our case is GitHub source. And then we identify the endpoint itself. In this case, it's issues. And then we use the apply hints function. And here we can override the original configuration that we gave it in the original config. What this means is that, here we can provide all the additional information we want without once again tweaking the configuration that we originally made in the Dagster pipeline script. So here I'm going to say incremental is equal to, and then dlt.sources.incremental. And then, of course, the first parameter is cursor path. And let me make sure that it is updated at. It is. So cursor path is updated at. And the next is our initial value. Okay, again, I don't want to have a hard-coded value here. So what I'm going to do is, let's just use a placeholder for now. But what I'm going to do is I'm going to create an environmental variable, which I can replace this argument with. So on top here, I'm going to say import OS. And I'm going to say initial value is equal to os dot get environment. And then I will name it, what should I name it? Issues initial value. Right? And I can go to the environment variable here the .env file, and I can create this environment variable, and I'll replace it with this original one. because I don't actually want to change the date as is. I just want to make it dynamic. So I can say initial value. And that's it. Let me do the exact same for our backfilling. So in this case, I'm going to say GitHub source .forks.apply hints. I'm a little lazy, so I'm just going to copy this. Kind of. I have to use a different initial value, of course. And then since this is a time window, because it's backfilling and not just incremental loading, we also need to have an end value. And again, I'll fill out those arguments later. And then the row order also needs to be included, which is ASC. So much like how we created, initial value for our incremental loading, I want to create two environment variables for the forks endpoint, one for the initial value and one for the end. So I'm going to say forks initial value equals to os.getEnv forks initial value. And I'll do the same here for the end value, forks end value equals to os.getEnv forks end value. Great. Oh, and I misspelled that GitHub source. So I'm going to replace these variables here. And we have our dynamic solution. We're not quite done here for backfilling. The difference between backfilling and incremental loading is something you want to implement every single pipeline run, whereas backfilling is more of a one-off job that you only do once and then you disable. So in our case, we don't want our pipeline to incorporate backfilling unless we want it to. So by default, I want this code to not run. And the way to do that is very simple. So we can add a second argument to this this get env, and that'll just be an empty string. And I'll do this for both of these lines. And what this basically means is if there's no initial value if there's no forks initial value in the .env file, then it's just going to return this default value instead. What that helps us do is it ensures that, unless we provide our initial value and end value for the forks endpoint, these two variables will be empty strings. And with that, we can add another piece of logic, an if statement block, and we can say if forks initial value and forks end value. And I'll put this code within this block. And what this basically means is, as the autocomplete says, you only apply these hints when both of these environment variables are set. Overall, what this means is that we have a dynamic way of activating and deactivating backfilling. If I want backfilling, I can go to the .env file and I can create those environment variables and then run the pipeline. And then when I want to deactivate it, I would just have to go back to the env file and get rid of those environment variables and let the script run as is. The cool thing is about this solution is for both the incremental loading in the issues endpoint and the backfilling in the forks endpoint is I only have to tweak the environment variables and I can leave the script alone and it'll run just perfectly as is. One more thing that we can do to improve this whole thing is by leveraging parallelization. As you know, with Dagster and its multiprocessing capabilities, we don't have to run the pipeline one endpoint at a time. Rather, we can run them concurrently and save us a bit of time. So here I'm going to show you how to do that. And I'm going to do this by creating a separate asset script on which I'll work on for this section. So I'll just create a copy of this so I can preserve the work we've done so far, and I'll just call this assets parallel. So here, I am going to go back down to the original asset we created, and I'm going to explain to you what we're going to do. Right now, we have one asset function, and we are using it to basically run the pipeline for all of the endpoints. What we will do instead is we will be creating multiple functions this time around, one function for each endpoint in the source. And we'll be having separate pipelines running concurrently, one pipeline per source. So here's what that's going to look like. So I'm just going to say def, and I'm going to say make resource asset, and our parameter is just going to be the resource name. And yeah, it's just going to be a string. So I'm going to put all of this inside this block, and I'm going to make a couple of tweaks to some of the arguments here. So just give me a moment. Okay, so firstly, this time around, we only want to run individual endpoints in each source. So this time, we are giving it the GitHub source, which has all 5 endpoints. This time, we only want the source to provide the config for one specific resource. And in DLT, that can be done with a function called with resources. And then inside this, you just provide the name of the resource. So that's pretty straightforward. All this does is, let's say that the resource name is issues. Now, if you provide this function, it'll omit every config inside the GitHub source that is not issues. So it's pretty handy in our use case. We want to have multiple pipelines running concurrently, one for each resource. And in DLT, what that means is that these pipelines need to have different names. If they don't have different names, if you have multiple pipelines with the same name, then that means that they'll all be running on the same state, and it's very likely that they'll interfere with one another, simply put. So I'm actually going to give them a different name, and I'll just be adding a suffix based on the resource name at the end. I won't be changing much else. I guess I can change the name. And again, I'll just include the resource name here. And that's it. And now all I have to do is just return the Dagster GitHub assets function. That's it. So that's all we're doing to change the function. But we're not done yet. This time, I want to run this function to be able to access this function, simply put. So I'm saying this because if we were to give the definitions this function as is, it's not going to recognize this as an asset because it's not. Our asset is here, Dagster GitHub assets. So I want to run this function once for every resource name and then give that output to the definitions. Sounds a bit confusing, but it's actually quite simple in practice. Let me just show you what that looks like. Resource names. I'm going to create a list of resources that we have. So here are all our endpoints in our config. There's a way to get these values without hard coding, but just for the sake of the demo, I just want to show you what we're doing. So we have all of our resources, and now I'm going to have create another variable called parallel assets. Is that how you spell parallel? How do you spell parallel? Yeah, there we go. And all I'm going to do is use list comprehension, and I'm going to call this function once for every resource in resource names. So I'm going to say make resource asset for resource in resource names. And that's it. So let's compare the difference between this script here that we've created and the original asset script we created, because it's going to help you understand what we do later on. So in this asset script, our asset is just this Dagster GitHub assets. Whereas here, our assets are actually in this variable rather than this variable. Actually, for naming convention, let me help them align. So I'll call this Dagster GitHub assets, and I'll add parallel to it, just so it's easy to follow along. So yeah, but same concept. This time, we want our definition script to access this variable right here because it has our assets in a list. Let's go to the definition script and we'll apply all the changes that we've made in our parallel script. So the first thing, of course, is our import line here. We want to match what we create in the asset script. So this time we're not in the assets script at all. We are in assets parallel. And rather than Dagster GitHub assets, we're using Dagster GitHub assets parallel. Remember, that's the name of this variable right here. And then I'll be modifying all the other scripts accordingly. So I'll be pasting this here in our selection parameter for jobs, as well as here for the assets argument. Now, we're not done yet because this variable is now already a list. Remember, because we're using list comprehension. So we no longer need to provide these brackets that we did initially. So we can get rid of these. And it's going to work the same. There's just one more thing we need to do to provide this in, to have this thing run in parallel. And that is to include the multi-process executor. So I'm going to add another line here in the import, and I'll use type linting later when I push this to GitHub to make this a lot prettier. But for now, we'll make do with this. So what I'm going to do is in our job object, which I created for a reason, there's going to be another parameter I'm going to include called executor def. And I'm going to set it to be multi-process executor. And I'm going to add configured. And I'm going to provide it this dictionary here called max concurrent, and then the corresponding value is the max number of workers. So in this case, it's 4. I'm going to leave it, I'm going to make it 5 actually, because that's the number of endpoints we have. Of course, if you want, you can set this as an environmental variable so that you can make this dynamic and not hard-coded. But for the demo, I think it's fine if we just leave it hard-coded for now. So that's it for the changes. As you might be blown away by how little or how few changes we needed to make to go from sequential to parallel. All we had to do was to add a few lines of code here and there and make a few tweaks. And yeah, we're able to run this thing in parallel. So let me run this thing actually in our UI to make sure that everything works. So I'll type in dgdev. Okay, let's switch over to our browser. 3000. Once again, I'll go to our assets and click on view lineage. And I'll materialize everything. Again, up till now, everything has been the same in terms of procedure for running it. When you're running something sequentially or in parallel, you don't really do anything differently. But when you go to the runs and you inspect the run, you'll notice that the actual procedure is different now. Instead of running everything sequentially, i.e. one after the other, you're actually running things concurrently. So you're running multiple pipelines at once. But yeah, that's the gist of it. That is how you implement parallelization with Dagster and DLT.